Hello, sixth grade math students. We are working on chapter 3 in Math in Focus. We have already learned how to divide fractions from lesson 3.1. We've learned how to use models for that and also the reciprocal multiplication method. Today we're going to work on lesson 3.2. We are going to work on multiplying decimals. So my goal for you is to apply the multiplication skills you already know with multi-digit numbers, but then learn where that decimal placement goes in our final answer. So taking a look at our first example here, I have 0 and 7/10 times 0 and 3/10. Oh, I want to use a benchmarking strategy real quickly. I want you to recognize that I can really ignore that decimal for a quick minute and at least get some good number information. Isn't the 0 and 7/10 kind of remind you, doesn't it, I should say, remind you of 7? And the 0 and 3/10, if I ignored the placeholder here and ignored the decimal for a quick minute, wouldn't it kind of be like saying 7 times 3? Oh, 7 times 3 is actually 21. So I know I need to get a 2 and a 1 in my answer somehow. So this benchmark strategy, I'm already familiar with how to multiply. I know I'm supposed to get a result that has a 2 and a 1 in it. And now we just need to talk about the decimals. So let's do a quick rewrite. And really, multiplication is commutative. So either number could go on top. I try to choose the number with the most digits. And in this case, they're the same, so I guess either one would be appropriate. I just grabbed the first one and wrote it in the first place or position. Let's go ahead and multiply and see how we will change this answer of 21 into a decimal answer. Well, what is 3 times 7? Hopefully you'd still say 21. We'll keep the 1, regroup the 2, and some students get hung up on this one, but be careful. 3 times 0 is actually 0 plus 2 more gets them that 2 sitting here. Well, I'm done with the 3, I can move over a place, but I hope you remember 0 times anything isn't really going to change this 2 and this 1 that I have down here in my product. So let's leave that alone for a minute. Well, looks like I got the same answer, but notice there are decimals here. I have to pay attention to those. So I'm going to introduce to you the decimal bank. And actually, we have seen this before in warm-ups and early in the year, but it's coming back at you, and this time for mastery. So I want you to actually gain this knowledge and keep it in your long-term memory. So take a look. How many place values do I need to move over to the left to get to the decimal? Well, the answer is 1. There's 1 jump in the first number. Well, next I look at the second number that I was given and I say how many jumps to the left does this decimal move? And the answer is 1 more jump. So just like in the bank where we like to save things, in this decimal bank we like to save place values. So I'm going to add these together. How many place values should we save? Well, 1 for the first number, 1 for the second number makes a total of 2. I want to save 2 places in the decimal. What that means is I move down here to my answer, which currently looks like 21, like a whole number, like the decimal's at the back. But I want to jump 2 places to the left. Oh, my new decimal home is here. This is actually 21 hundredths. I might want to show a 0 up front to make your 7th grade teachers extremely happy. They kind of look for that, I hear. And I want you to go back and look real quickly. If you're wondering why this works, it's because of this. This 7/10 is actually a 7 divided by 10. We divided by 10 one time to get that decimal over one place. And this 3/10 is actually 3 divided by 10. I divided by 10 one time to get that decimal to jump one place. Well, if I divide by 10 and divide by 10 again, technically I could have just divided by 100. So that's what we do here in our answer. We divide by 10 and 10 again. We're actually dividing by 100, and this lands in the hundredths place. This is a good final answer. It's kind of unfamiliar because I think a lot of us are so familiar with our addition subtraction rules where you can drop down the decimal. That is not something we can do in multiplication. So I want you to just remember multiplication and division with decimals, they have some special rules. And today our multiplying involves the decimal bank. Okay, decimal bank. Let's take a look at our second example. Well, I really could use benchmarking, but I don't really know what 12 times 35 is off the top of my head. So instead, I'm just going to write it out with the decimals included, and I'm going to build the decimal bank. Remember, I told you I like to grab the most digity number. I don't know if that's a word, but it sounds kind of fun. So we'll grab the number with the most digits. That happens to be this number. It has 3 digits. And underneath it, I'm going to write that 1 2/10. Notice, I do not care about my decimal alignment. These decimals were aligned on the last problem. They aren't this time. No big deal because we are multiplying. Well, Let's shield our eyes, ignore that decimal for a quick minute, and we'll move that decimal in when we're ready at the end of our multiplication. So let's use our algorithm. Let's multiply like we know to do. 2 times 5 is 10. We keep the 0, we regroup the 1. 2 times 3 is 6, plus 1 more gets me 7. 2 times 0, if you want to show it, is a 0. Doesn't really affect things, but we could show that placeholder up front. I'm done with this too. I want to move over. I need to remember to move over a place value. Sometimes we call this Bob. Thanks, Bob, for saving my spot. Let's move to the 1, and let's multiply 1 times 5, which gets me 5. And let's multiply 1 times 3, which gets me 3. And if you want to multiply 1 times 0, it still is 0. And I'm going to go ahead and add up my two products. All right, 0 plus Bob, 0. 7 plus 5, 12, and we regroup the 1. 1 plus 0 plus 3 is 4, and nothing out front. Ooh, looks like I got an answer of, this is kind of like 420, isn't it? I could take off that front 0, it's not really necessary. So this looks like 420, but that's dangerous because if you notice, I had 1 and 2/10, which is really close to 1, isn't it? It's kind of close to 1. And I was multiplying by something smaller than 1. Something smaller than 1. This almost looks like 35 cents, doesn't it? It's like saying one group of 35 cents. Oh, 1 times 35 cents would still get me 35 cents, wouldn't it? So I really want my decimal to look like I'm landing in a number or a place value that's going to get me close to 35 hundredths. Well, how do I do that? Well, one way is to think about the bank. So, oops, I'm trying to erase this for us so we can draw our decimal bank. That was just thinking. And right now I need to show some serious work about my decimal bank. So we start at the back of our first number we were given in the problem, and we count 1, 2 jumps to the left. I need to save 2 places in the decimal. The next number I was given was 2/10. The decimal was moved over 1 jump to the left. So I'm saving places in the bank. I'm saving places in the decimal. So I'm going to add these together and figure out how many total places we should save. Oh, 3 jumps, 3 hops, some people might say. So I come down here to my answer, and I start at the back like it's a whole number and divide by 10, 10 again, 10 again. Or I make sure that I make 3 jumps heading to the left. I could do that also down here if you'd rather see it. And I might even put the 0 out front as a placeholder. 7th grade teachers like to see that. Oh, they really divided this number by not 10, not 100, but 1,000. I end up with 420 thousandths. That's pretty close to that 35 hundredths I was thinking about. In fact, you could rewrite this. You could take off that back 0, couldn't you? And it would look very close indeed. So, friendly reminder, we multiply like always. We use multi-digit multiplication steps like you have since the elementary. And what you need to remember to do when you're done, build the bank. We build the bank. When you multiply, you think of things getting to be more, or maybe things are growing. Well, you want your money to grow in the bank, just like we want our place values to grow in the decimal bank. All right, here goes. We have a third example before we call it good today. So we're going to take a look at this last one where it says I have 6 times 8 and 59 hundredths. Hey, this almost looks like money, doesn't it? So if I have 6 groups of lots of money, it seems like I would end up with my answer looking kind of like money. Just kind of right, if I remind myself, I kind of want this to end up looking like money just because this goes to the hundredth place, doesn't it? Well, we grab the most digity number, if that is such a thing, and we'll write it on top. We're going to stack the numbers we're given in multiplication. And I'm not stacking the decimal, not needed. I'm multiplying, so no decimal alignment necessary yet. Here we go. We're going to multiply like we always do. I will point out some students like to show these placeholders so that you know there's some zeros under here. Just helps them kind of keep things in order. I could have gone back to do that in this previous problem also. Maybe you need to see a placeholder there just so that you're not confused. Well, let's give it a try. What we'd say is 6 times 9 is 54. We keep the 4, regroup the 5. 6 times 5 is 30, plus 5 more, 35. We'll keep the 5, regroup the 3. 6 times 8 is 48, but I have to add 3 more. 49, 50, 51. 51. Whoa, this doesn't look much like money at all. And in fact, I could multiply all these zeros, and I see lots of students like to do that, but is it necessary? Isn't 0 times anything 0? And when I add all those zeros on, is it going to change my digits at all? Nope. This is good enough for me, but it doesn't look like money, or it looks like too much money if you ask me. So I know I need a decimal bank. To build the decimal bank, we're going to write off to the side maybe a giant B for bank or decimal bank or however you want to indicate this. We want to count our decimal places in the first number. How many places over or hops did the first decimal make? 2. 1 and 2. How many decimal jumps did our decimal make in the second number? Oh no, I don't even see his decimal. Where is it hiding? Well, the correct answer is all whole numbers have a decimal, but they're at the back. We don't usually show those, do we? But we will in this situation just to help you out. So if the decimal's at the back, did it have to hop at all? Absolutely not. It took 0 jumps. So let's total up our bank. How many place values or hops will we make in our answer? 2 plus 0 is 2. We need 2 total jumps. So remember, where do we start? Do we start from the front, from the middle, from the back? Where do we go? Well, we always start like it's a whole number, and we change it to a decimal by hopping a total number of jumps. So in this case, 2. 1, 2. Our new decimal home is sitting here. This does remind me of what we talked about earlier. It looks like money. And in fact, $8.59 is kind of close to $9. And $9 times 6, 9 times 6 is, let me think here, 54. My answer is pretty close to 54. I'm using estimation to make sure that my answer is reasonable, and it is. This is a great final answer. That's all we need to do. Again, your goal today is to learn how to multiply decimals, and we multiply like we always do. We use multi-digit algorithms for multiplication, and when we're done, we build a decimal bank. So that's what we've practiced here. Total up your hops and move that many times in your answer. And again, it's a total number of hops, starting at the back of the number and moving forward. Sometimes you'll have 1 hop, 3 hops, 5 hops. Sometimes there will be none if there are no decimals showing and you're only working with whole numbers.